this video we'll discuss proportional relationships. Now we can represent a proportional relationship as a linear equation where we use the unit rate as the slope of the line. When we taught this in algebra classes, we often called this a direct variation relationship. So let's go back to our example of using 3 teaspoons of salt for 4 teaspoons of pepper. When we looked at this before, we said that we can recognize that we can look at pepper as our one group, which means then that we have, when we look at salt, there's 3 parts out of the 4 needed to make a whole group. So we'd say it's 3/4 of a group. So we said that that would mean that our amount of salt is 3/4 of a group times however many groups of 1 teaspoon of pepper that we have. So if we made a table, say we had 2 teaspoons of pepper, we knew that we could do 3/4 times 2 and get 1.5 teaspoons of salt. If we made 4 teaspoons of pepper, we could then plug that in and see that would give us 3 teaspoons of salt. If we did 6 teaspoons of pepper, we would see that would give us 4.5 teaspoons of salt. So in essence, what we know is that if we take p teaspoons of pepper, we know that 3/4 times p will always give us the amount of salt we need, or S. And there's that direct variation equation that we have. Now there's a very common error that students will make with this, which is thinking that they can write the ratio as an equation. And the ratio is not an equation. The ratio is a ratio. So when we look at this example, we know that we can write the ratio as 3:4. And what we'll see sometimes is students will write this as 3s equals 4p. And if they rewrite it to solve just for s, they'll get that 3 equals 4/3 times p, which, go back to where we just were, we knew that it was actually 3/4 p. And the reasoning is that here we're treating this as multiplication. Instead of, when we're looking at the ratio, we're saying 3 parts salt to 4 parts pepper. That's not the same as multiplying and saying 3 times the parts of salt equals 4 times the parts of pepper. It's a very different understanding. So we want to make sure we don't make this mistake. And that's why we think about how do we set up the unit rate as a way of going through it. So that's why we say what makes one group, and then how do we relate the other one. And we see here again, it only makes 3/4 of a group of salt. Hence that salt is equal to 3/4 the amount of pepper. So the common error students make typically creates the reciprocal of what should be the slope of that direct variation equation. So we want to try to avoid that. So say you want to actually go through and graph the proportional relationship. What I'm going to do here, I'm going to start the same problem again, trying to follow through. What we can go here is, we know then, as we've said, that S would equal 3/4 however much pepper we had. So we could say that that's the same as y equals 3/4 x. That's the direct variation equation that you would commonly see in an algebra class. And that's because that the amount of salt depends on how much pepper we put in here. In other words, the y value depends on how much x we have. And we can create a table and use the table to graph. So here I have a graph, same data we've already had, except now I've added 0 and added just another point of 8. And we know that if we put 0 teaspoons of pepper, we're going to put 0 teaspoons of salt, which is one of the nice things about the direct variation equation, especially when we talk about a real-world situation. We know that these equations and these proportional relationships will always start at 0, 0, because without any pepper, we have no salt. Now let's look at what happens as we go from one amount to the next, because you see that we've made it so that all the pepper has the same distance that we're looking at. So it's always increasing by 2 teaspoons. So for my 2 teaspoons of increase of pepper, I increase 1.5 teaspoons of salt. Again, a 2 teaspoon increase led to a 1.5 teaspoon increase in salt. And I see that is true between the consecutive values. That's always increasing by 2 for my amount of pepper, which leads to an increase in 1.5 teaspoons of salt. So I can now plot these points on my coordinate plane. So I got 0, 0, then 2, 1.5. So I go x values 2, my y values 1.5. Then I'm going to go to 4, 3. Then I'm going to go to 6, 4.5. And then I'm going to go 8, 6. And I can see that I can draw a line through those points, and that is all the different values that exist on that line. Not just the ones that I showed, but all the values that show up on that line are the ones that would make this statement true. That if I take any value for the amount of pepper, it would give me the corresponding amount of salt on this line. Now the question though, and you can see here, here's my rise, 1.5, and my run of 2, and that's between the points that I chose. I can see that rise and run of 1.5 to 2. But the question then is, but we said here that our equation, that the slope should be 3/4, but here we're getting 1.5 over 2. That doesn't make sense. So why is the slope not 3/4, as it should be? Well, let's go and actually simplify 1.5 over 2. So with 1.5, we're going to change that to its improper fraction, which is 3/2 over 2. Now, if we want to do 3/2 over 2, that's the same as saying 3/2 times 1/2, because we keep our numerator and we're going to multiply by the reciprocal of the denominator. And when I do that, 3 times 1 is 3, 2 times 2 is 4. There's my slope of 3/4. And I can actually look at this and see it on the graph as well. Say that I go from 0 to 0. If I rise 3 and run 4, that takes me to the point 4,3. If I do it again, that takes me to the point 8,6. And I could have done it between any of the 2 points. It's that that ratio will always simplify back to 3/4. And again, that's because we're keeping that proportional relationship through every ordered pair that will fall in this line, y equals 3/4 x.